All right. Writing two-step inequalities. This is the last portion to our unit. So again, tomorrow you guys are going to be having a review. We're going to play Bing.
Bingo?
The bingo game that we played, where we have lots of people who can win different ways. Yeah, we're going to play that tomorrow. Oh, okay. Well, you'll play. It's fun. All right, so all we're going to be doing today, guys, is translating from words to the actual inequality. So you need to know some of the keywords for what inequality symbols you would be using, but you also need to know your keywords for your operation. So the quotient of a number and -8 is at most -6. So given a situation like this, what you're wanting to do first, before you even start writing down the operations or what's happening with x, the first thing that you want to do, identify the inequality. Find the phrase that represents an inequality statement. So who can tell me in this problem which phrase up here is representing a greater than, a less than, a greater than or equal to, or a less than or equal to statement? Justin? At most. And not just at most, is at most. Because remember, less than means subtraction. Is less than means the less than symbol. So you have to know the difference between when less than is a subtraction and is less than. That keyword is represents that it's going to be that inequality. So it is at most -6. Is at most -6. What inequality is the is at most? Is that a less than, a greater than, a less than or equal to, a greater than or equal to? Kingston. Less than or equal to. Very good. Is at most means that that's the most it can possibly be. A 100% is at most the highest grade you can get. That's the highest possible grade you can get on your test. 100%. Okay, so is at most means it can technically be equal to it, so we can draw the line underneath, but it also could be less than this. So it's less than or equal to a -6. Now the rest of it. The rest of it is where the operation with your variable occurs. So we're talking about the quotient of a number and -8. Quotient means what operation? What operation is quotient, Joel? Division. So quotient means you're going to divide. And if you need to write this up at the top, I think sometimes you guys forget. Sum means what? Add. Difference. Subtract. Good. Okay, we just said quotient. Quotient was to divide. And who remembers which one is multiplication? What do we call that? Product. Very good. Product means you're going to multiply. Okay, so those are some words you need to make sure you remember. Okay, so we know that we're going to divide a number, so x, and -8. So we're going to set it up as x over -8. That's the setup. Now we need to solve it. So once you've got it set up, you now need to be able to solve it. What operation would we do to solve this? What inverse is that going to be? Multiplication. Good. So first thing, I should have an alarm going off in my head. I'm multiplying by a -8. Why should there be an alarm going off in my head? Joel? It's because you're going to have to flip. Because we're doing multiplication by a negative, remember I always like to circle that negative, we're multiplying by a -8, that means I'm going to have to flip it. So the inequality is now going to become greater than or equal to. And since I'm multiplying both sides by -8, what's a negative times a negative? positive, and 6 times 8? 48. Good. So we get x is greater than or equal to 48. X is greater than or equal to 48. Twice a number is at least negative 10. Twice a number is at least negative 10. What's the inequality phrase? What inequality phrase should I be seeing? Bryant? At least. Is at least negative 10. So is at least negative 10 means what inequality is at least? Julian David. Not less than. Greater than or equal to. It's greater than or equal to. You must be at least this tall to ride this ride. That means this height or taller. Is at least means that it has to be greater than or equal. So it has to be greater than or equal to negative 10. Greater than or equal to negative 10. Okay, the other portion. Twice a number. What is that representing? Multiplication. So that means it's going to be 2 times x. We get 2 times x. So there's our statement. Now we need to solve it. What inverse operation to solve? Division. And what are we going to divide by? 2. Are we going to keep or flip? Keep. We're going to keep. So we're going to divide both sides by 2. We're going to get x is greater than or equal to negative 5. All right, so those are just some basic translations from Word to inequality statements. Now you might also have real-world situations, some real-world problems that you're going to have to be able to translate amongst. I think this stuff, these things, you guys have an easier time with. It's the real-world stuff that you have a little bit more difficulty comprehending. So let's say that Kim is reading a book. She wants to read a minimum of 150 pages by the end of the week. So far, she's read 20 pages. If there are 5 more days left, write an inequality to represent how many pages per day she needs to read. So just like before, when you've got a problem like this, you got to look for the inequality phrase first. You want to look to see, okay, which inequality statement do we see so that we can at least set up that part. That's probably the most difficult part. is identifying the inequality. A lot of times you guys set the equations up correct, but you get the inequality wrong. Like you might put it's a less than when it's supposed to be a less than or equal to. Or maybe you put less than or equal to and it's supposed to be a greater than or equal to because you got the verbiage mixed. So you need to make sure that you are studying those vocab phrases. Who can tell me in the problem what key word or phrase is representing an inequality? Abigail? Minimum. It says that we want to read a minimum of 150 pages. A minimum of 150 pages. Who can remind us what inequality is minimum? EJ. Greater than or equal to. Minimum means it's greater than or equal to. This is the smallest amount that I'm going to read. So I want to read 150 pages, but I could also read more. That's the minimum that I'm going to do. It's kind of like sometimes when we talk to you guys about the effort that you put into class. You've put the bare minimum of effort into your homework or a bare minimum of effort to studying. That means you did the least amount of work possible, but you could have done more. Okay? Minimum, greater than or equal to. So we know it has to be greater than or equal to 150. So now the next part, that's the easy stuff. Remember, a constant is a one-time value or a starting value. Do we have a one-time value or a starting value up here? Joel, 20 pages. So far, she has read 20 pages. That's going to be our constant because that's what we're starting with. We started with 20 pages. Now she needs to continue reading more. So we're going to add on to those 20 pages. So that leaves us with a coefficient and a variable. What's the coefficient? The 5, right? She needs to read a certain amount of pages every single day. She's only got 5 days left. So she's got 5p. 5 days with this amount of pages left to read. 5p. P representing the pages. And there's your inequality. 20 plus 5p is greater than or equal to 150. You could also write it as 5p plus 20 is greater than or equal to 150. That's perfectly fine as well. What's the first thing we would do to solve this? Subtract, and then what? And then divide. I'm not going to go into it because at this point you guys know how to do that. I'm just focusing on you setting it up. You can set it up, you can solve it. Okay, so we know we would subtract 20 and then we would divide by 5. That would let us know the bare minimum that she needs to read per day. All right, I'm out of room. Go to the next page, 75. Because I write big. I do. All right, for Halloween, I want to give at least 48 goodie bags to trick-or-treaters. My daughter and her 9 friends will get a goodie bag as well. How many trick-or-treaters am I going to need to come to my house so that I'm satisfied that I've gotten at least some of my goodie bags gotten rid of? So, true situation. So for here, let's first set up the inequality. What's the inequality statement, the phrase that I'm looking at? Look through the problem, find the phrase that represents an inequality. So, Jordan? At least. At least 48 goodie bags. So at least is going to be my inequality statement. And Jordan, what does at least represent? What inequality is that? Very good. Greater than or equal to. So it needs to be greater than or equal to 48. I want to get rid of at least 48, but I'm happy to get rid of more. Not happy if I get rid of less. So 48 or more is what I'm going for. Now, my daughter and her 9 friends are going to get a goodie bag. So how many trick-or-treaters do I need to have come to my house in order for me to be satisfied? So how many people am I starting off with? I'm starting off with 10, right? My daughter and her 9 friends, that's 10 people. So I'm already getting rid of 10 of them, aren't I? So that's 10 people that I'm already starting with, plus I need the rest of the trick-or-treaters to come. So this is my statement. 10 plus X is greater than or equal to 48. So Jalen, you second-guessed yourself, and you shouldn't have. You were correct. I need at least 48 people to come to, or 38 people to come to the house in order for me to be satisfied. Okay? Again, I'm just setting it up. I'm just showing you how to set it up. From here, you guys would know how to solve. Let's try another one. Are you complaining? I'm the one who writes this every single day for multiple class periods. Sorry, that should be a 250. Let me go ahead and cross that off. Nope. All right, a gift card has $250 on it, and I want to buy a pair of boots for $100. And there are also some scarves that are $30 each. So I want to write an inequality to represent the most scarves that I can buy. So here, there's really not an inequality statement or a phrase, but there is a scenario. Who thinks they know what is the inequality? God bless you. What is the inequality going to be? What do you think, Joel? Why do you say less than or equal to? Okay, so she's got a gift card, right? Gift card has 250. So you have to ask yourself, can you spend less than 250? Do you have to spend the whole gift card, guys? No. Can you spend exactly 250? Yeah. But can you go over the amount? No. So that means a gift card naturally has that cap off limit. You have to, if you're going to use only your gift card, then your purchase has to be less than or equal to the amount that's on the gift card. That's just a natural idea for an inequality. It has to be less than or equal to 250 because it is a gift card. You can't exceed your gift card limit. Now, from there, I want to buy a pair of boots for $100 and I want to buy some scarves that are $30 each. What's my constant? What's the one-time purchase? Jasmine? The boots. The boots are a one-time purchase of spending $100, guys. And then we've got the $30 each for the scarves. And I want to know how many scarves I can buy. So am I looking for more than one scarf? Yeah. If I want to know how many I can buy, that means I'm looking for more than one. So I've got $30 per scarf, so 30x. And there's my inequality statement. Again, I'm just showing you guys how to set them up. You know how to solve from here. Yeah, this next one's going to be on your own. I said I'm not going to solve them. You guys know how to at this point. Huh? It's not. 3 years ago. I went back through my records. I knew it was something 78. I thought it was 178, but when I went back through my records, it was 378. All right, the most pink links Mrs. French-Zheng's class has ever bought is 378. This year, her homeroom wants to break the record. They have already purchased 102 links. If there are 22 students in the class, write an inequality to represent how many links each student needs to buy. Again, you are doing this one on your own. You're going to just write the inequality. I'm not asking you to solve it. I just want you to set the inequality up. All right, what's the inequality? EJ, greater than, how do you know? You want to break the record. So if you break a record, can you be less than that?
No.
Can you be equal to it? No. Breaking a record means you have to be greater than it. So you have to be greater than 378 in order for you to break the record. And what is the other side of the inequality going to be written as, Julian? Julian. Very good. 22x plus 102. They already have 102 links so far, and now there's 22 students to supplement the rest of them. So it'd be 22x plus 102. Then you would solve it. That's it. What you guys need to make sure that you are doing, you have IXL and Prodigy game that needs to be completed. If you have not completed it so far, then you need to make sure that you're getting on and getting it done. It is due tomorrow. Tomorrow is the last day to go ahead and get it done. Tomorrow by midnight is the last chance that you have to get the stuff done. Now, here is the information that you need to make sure you keep in mind. You are doing IXL 7th grade material. T1, T2, and T3 need a SMART score of 70%. T4 and T6 need a SMART score of an 80%. This needs to be finished by tomorrow night. If you plan to do the extra credit, which is T5 and T7, those were also a 70%. They don't need to be done until Friday. And I'm going to tell you one thing. If you do T5 and T7, but you don't do these, I'm not giving you the extra credit. You have to complete this first before I'll accept these as extra credit. You also have to get your Prodigy game done. It closes tomorrow night. So you won't, at least with IXL, you go in, you keep working, even if I said I sent the information to myself. With Prodigy game, once I set a limit to it, it closes the assignment and you won't have access to it anymore. You can still get on Prodigy and you can still play, but it won't ask you the questions for the assignment. So you need to get Prodigy done first. If you have a device, use your device now to get on. If you don't have a device, log onto a computer. Shut down, honey. You gotta go at the very, very, very beginning of class. Hold on, let me get this turned off.